Okay, so this was this open-ended question or the investigation. We wanted to find out what N was, and we've all done, we invested $5,000 at 6% per annum. So this is the compound interest formula. And the question was, how many years before this 5,000 doubled? And we could do this by trial and error. We could do 5,000 times 1.06 to the power of, and we could guess, maybe 4. And we can do that on a calculator. 5,000 times 1.06 to the power of 4. Okay. And what does that give us? It's only 6,000. So we'll need a bigger one. So 5,000 times 1.06 to the power of, let's try not 4 this time. I hope I don't. Yep. Let's try 7 years. 7 years, that's only 7,000. So we're still not close enough. So and we can keep trying for trial and error or guess, check, refine. Is there a better way to do it? Okay, and this is where log laws come in, or using logs come in really, really well. Anytime the unknown is in the power or in the exponent, we can use log laws to find it without using guess, check, and refine. So let's see how we do this. We're going to divide by 1,000 here. That's a nice simple step. And we get 2 equals 1.06 to the sum power of n. And straight away we simplified it, but still n is in the power and we'd still have to go through and try different numbers until we got it. So what we're going to do is we're going to take the log of both sides. We're going to take the log of 2 and we're going to take the log of 1.06 to the power of n. Now, one of the great things about the log laws is that when you've got something like this, we can just straight away bring that down. So if we look at a nice example, let's do the log of 20 and let's do the log of 20 squared and the log of 20 cubed. Okay, so let's do the log of 20. What is the log of 20? The log of 20 equals 1.3. And we'll keep it fairly simple. We'll just do it to one decimal place, 1.3. So I'm saying the log of 20 squared would be 2.6. What's 20 squared? 400. The log of 400, I'm going to say 2.6. There it is, 2.6. What's 400 times 20? 8,000. So let's do the log of 8,000. I'm going to say it's 3.9. And there it is at 3.9. So you can see when we do the log of 20, that's that. The log of 20 squared is really 2 times 1.3. The log of 20 cubed is really 3 times 1.3. How does that help us up here? Well, we can take n out the front, just like we took it out the front here, and we can write that as the log of 2 equals n times the log of 1.06. Always the same sort of process, but why does it work? It works because of the way we've worked it over here. It works because it's this log multiplied by that, and that way we can bring it out the front because it's the index laws and the log laws. What's our next step? We just do n and we divide both sides by the log of 1.6. So the log of 2 over the log of 1.6. And we can just do it again. We can do that on our calculator. The log of 2 divided by the log of 1.06 equals, and I've got 11.89. 566,105. Okay, 11.89566105. Okay. If we go back to our first question, what we are saying is 5,000 times 1.06 to the power of 11.89566. What should that equal? It should equal 10,000. So let's have a look. We've got 5,000 times 1.06 to the power of, and what was it? 11.89566,105 equals 10,000. So using our log laws, instead of guessing and checking and finding that the unknown when it's in the indice, what we can do is use our log laws and find it in one step. And that's the whole power of the log laws. Thanks.